community hates tools, that we hate software, that we only drive wooden cars, that we only use natural soaps or whatever. We don't vaccinate our children, whatever it is. That we hate automation. Now this is not true. I started as a production programmer before I was ever a tester. I'm proud of the fact that I use my technical skills whenever I test. And I used to be real snobbish about the fact that I thought every tester should be a programmer. I no longer think every tester should be a programmer. I've met too many excellent testers who hate programming, but they can work with programmers, they can make programmers better, they're wonderful. My brother is one of these people. He's a brilliant test manager and he doesn't code. He doesn't want to code. So that convinced me not everyone has to be a programmer. But I'm a programmer and I write tools all the time whenever I'm trying to test. So it's weird for me when I warn people about tools and then they say, oh, that must mean you hate tools. That must mean you never want to use automation at all. So we wanted to write this article. We started writing it a year ago, more than a year ago, about 14 months ago. And it took us several months to get the first draft out. And finally we got together for a few days in July and we thought we finished it. But we have this thing, we have this discipline, which is put our article out for review. We think it's done, but maybe there'll be a few words we need to change. So he put it out to about a dozen of our friends, and some of them hated it. And I got so angry that I couldn't work on the article for about 8 weeks. We just put it aside because all these comments came back. And it was a good thing we cooled off. I cooled off. And then we went through the comments, we went through all the comments, and we substantially rewrote the article based on the fact that everyone misunderstood what we were saying. So we added details and we added sections, and it grew into this 27-page article. And then I delivered it to Keith Klain right as he stopped working for Doran Jones. So we were going to give it to Doran Jones, the company, and then I no longer have a relationship with them. So we just published it on our own websites. And it's out there. It's a 27-page article. You can read the article. Hype wanted me to do a talk on the article. I didn't have any slides, so I just whipped some stuff together. So for those of you who are too busy to read a 27-page article, I'm going to go through some of the highlights of this. And I urge you to interrupt me, corner me like John Paul did, yell at me, whatever you want to do, raise your objections. We'll see how it goes. So here's one of the pictures we used in the article. Automate the boring stuff in Python. I want you to look at this picture and think about what the implications are here. I'll point out some things, some salient facts about this picture. This picture involves a tool using a tool. Okay? No humans are in this picture. There's not even any humans in the background. There's no humans out on their lawns. They've left it to the machines. I don't know where the humans are. They're not enjoying the day though. Notice that there's no broken down robots in the background. In real life, when I do automation, lots of my stuff is broken much of the time, but apparently not in this world. Notice that the robot that is doing the lawn mowing, so that the human presumably doesn't have to, is shaped like a human. That's really interesting. Because when I use tools, very few of my tools pretend to be a human. I don't even think of that most of the time. Like, I want to write a tool that pretends to be me. It never occurs to me. I heard somewhere of some IT guy who wrote a whole set of automation scripts to send texts to his wife and basically pretend to be him. If I ever did that and my wife found out, she'd she'd divorce, she'd never trust me again. That would be like the most horrible thing that I could possibly do, is write a tool that impersonated me and trick her into thinking that she was talking to me. That must be one of her nightmares, is that she's actually talking to a robot instead of her real life husband. So I don't understand how that can work for this guy. I don't use tools to pretend to be humans, except in very rare and limited circumstances. I use tools all the time to help my testing, tools that make me better, faster, stronger, tools that augment my capabilities as a human, but never tools that replace my capabilities as a human, or I should say, very rarely tools. Maybe for certain limited circumstances I might do that. But it's never my philosophy to do that. And yet everywhere I go, people talk about test automation, and the first thing they want to do is, are you a tester? The first thing they want to do is get rid of you and have a tool do your work instead, so they don't have to see you every day. Like, go away. How can we get rid of her, please? That's what they seem to want to do. Let's get away from the icky humans as fast as possible. I want you to notice that one of the greatest robot inventions in the history of Western civilization, I would say arguably, is the washing machine for washing clothes. It used to be actually really labor intensive to wash clothes. And now it isn't, because of washing machines. Washing machines are robots that wash clothing. They don't look like robots. They don't try to pretend to be humans. You never worry about your washing machine deciding, I don't want to do this anymore, and taking over your house and locking you out of it, walking around, deciding to kill your dog or whatever. You never worry about your washing machine doing that, because it is designed as a tool that has a very narrow purpose. We're actually surrounded by robots, but none of them look like humans or are trying to be humans, except, disturbingly, telemarketer robots. Maybe you've encountered these people. They actually sound like people, but you can tell they're chatbots because you give them nonsensical answers and they don't react the way a human would. They just kind of ignore what you said and repeat what they said before, and you go, oh, you're a chatbot, aren't you? I assure you, I'm a live person. You're a chatbot, aren't you? I assure you, I'm a live person. Well, that sounded really like the same thing you said the last time. Are you sure you're not a chatbot? I assure you, I'm really a live person. That kind of thing. It's so insulting. Like, do they really think that they're gonna fool me? Then of course the fear is maybe they will someday be that good that they'll fool me. When AI gets good enough that it actually fools you, it'll be just like going on a date with a real jerk. Someone who will fool you into thinking he cares about you and then won't call you back later because you didn't click on his link to buy his product or whatever. It'll be like that. AI will someday get really good, but we'll just be dealing with people that we realize, oh, that AI is a real jerk, real asshole. It's very complicated to make a human-like robot. Very, very complicated. That's why they don't exist. Or if they do exist, they're very advanced and incredibly expensive. There is a robot that Boston Dynamics creates. It can actually walk around a forest, and it can slip on ice, and if it slips over, it can get up again. It's kind of amazing. It can pick up boxes. This guy is very advanced, very expensive. So not quite this good yet. I did a search for actual robot lawnmowers. And guess what? It's not a little robot guy pushing a lawnmower. It's just a lawnmower without a handle on it that goes around. So this is completely worthless and redundant to have this guy out here. So I'm just kind of wondering, when I look at this picture, what did the guy who wrote this book, what was he thinking when he wrote this? Was he thinking, oh, what a cute robot guy? That's just like what I do. If so, he doesn't really think much about what he does. That's not what it's like. But it's sort of a fantasy. It's a fantasy that I can write a tool that will replace people, and then finally everything will be quiet and I can get my work done when all the people are dead and gone. I think there's something really disturbing about that. This is what I think people are trying to do in most of the time when they talk about test automation. What they're trying to do is automate testing by automating the user. One of the guys who commented on our article said, I don't think that's what people are doing, he said. He said, I think management wants to automate the test steps that the test analysts have created. Yeah, that's exactly what that is. That's what that is. Because what are those test steps? Those test steps are things the user does. So what I'm talking about is people think of automation as let's have a machine pretend to be a user. That's exactly what most people do when they write their quote test cases. They just say, here's what I would do as a user to use the product, and that will have the effect of exercising the product and testing it. This is very little imagination that it takes to think of automation this way. All around the world, everywhere I go, this is the first thing that people seem to be thinking about when they say test automation. I want to release people from the prison of thinking narrowly and in silly ways about this. One reason for that is if you try to automate and in such a way that you're replacing human, you end up with stuff like this. You end up with tools that connect to tools that connect to tools that try to interface with the GUI, and then you have to hack your way around an incompatibility in Chrome that breaks as soon as they upgrade Chrome, and then you want to do it in Firefox, and whoops, it's not compatible with Firefox unless we write a special plugin. Let's write a special plugin. And then you try to write the special plugin, and everything's fine until there's a security upgrade or something, and then it still doesn't work on the Edge browser, etc. So you add more and more little things, and you add some toast for the parent, and if you go away for a few days, they call you at vacation saying, it won't run. It's giving me 503 error. What's going on? Like, oh, I forgot. You have to reboot the server, and did you re-provision the EC3 server, and you can never actually have a vacation. That's what it felt like when I was running so-called test automation efforts at Borland International in the early 90s. All of our automation seemed like it was always either falling apart or just about to fall apart. I felt like I was building an F1 car, and they're always crashing, wheels are flying off of them. We're always operating at the upper limits. I remember we celebrated one day because we figured out a way that if the power went out, we could make the automation wake up again when the power came on and pick up exactly where it left off. And we thought that was so cool. We bought special plugs that were software controlled so that we can control the power and automatically reboot systems that had crashed. That was cool. Later we found out that all of our automation was totally worthless, but at least the power outage couldn't stop it, but it didn't actually find bugs or help us in any way. How did we learn that? We learned that because I hired a guy from IBM who had 9 years of testing experience. I had 5 years of testing experience at the time. He had 9 years. He's much older than me, so he wasn't very scared of me. The older I get, the more I worry about the fact that I work with people younger than me. And it's hard for people younger than me to talk back to me and argue with me because I'm more and more like their daddy. But when I was 25 years old, no one had that problem. They would just say, I disagree with you, and I wasn't the same kind of intimidating character. So this guy, he said to me, third day he's working for me, he said, I looked at your automation. I think we need to do a review of all the test programs. I said, we don't have time for that. There's 450 test programs. So he said, well, I think we should do it. Well, you're from IBM. Of course you're going to say that. Next day he comes back and said, I really think we need to do a review. I said, look, dude, there's no time. This is just a Silicon Valley. You're at Borland International now. We're the Borland barbarians, not the processarians. There's no time to do that. Third day, he comes back to me. He says, I did the review of all the programs and want to discuss the results. I said, how could you review 450 programs that we've been maintaining for 2 years? He said, well, it's really easy. Most of them don't do anything. You can just look at them and see. They don't even load the program to test. I couldn't believe it, but he was right. I had decided that it was too hard to review the code that had been written by people on my team, especially the code that was written before I joined the group. I assumed it would be complicated and too difficult. He didn't make that same assumption. I learned a lot from this guy. I learned, don't make assumptions that it's too hard to do something. Just try to do it first. Then if it's too hard, you'll know. But don't assume it's too hard. So what he did is he said, look, all this software is supposed to test a debugger. Now, you might not know much about debuggers, but how a debugger works is the debugger is a piece of software that loads a program and then walks through it and sets watches on variables, and it basically watches another program run and controls it while it's running. My group was testing the debugger. What he noticed is, in almost all the programs that were supposed to be doing testing, it never asked the debugger to load any process to do any debugging. It was like trying to test Microsoft Word without loading a document. So what was happening is the software was just going and saying, this menu is supposed to be all grayed out because none of these things are active. Is it really grayed out? Yep, pass. Yep, pass. Yep. Here's the online help. Let's take a picture of it. Let's page down. Take another picture. Page down. Take another picture. Page times 500. Pass, pass, pass. Look, 500 passes. It's all just pictures of the online help. Why did my team do this? When I confronted them, they said, well, we thought we should have as many tests as possible. And it's hard to automate those tests that actually do debugging. It's really complicated. So we said, what would be the easiest tests? And we automated all of those. That was our strategy. Some of you may have heard me say in some talk somewhere or online how counting test cases is the ultimate nonsense, totally meaningless and stupid. Now you know why I feel so strongly about this. All these test cases, and I was getting these reports every day saying we ran the tests again, 250 tests passed, or 462 test steps, all of them passed, and I just swallowed it like the biggest sucker in the world. Until I hired a guy who talked back to me. That's why I love hiring people who will argue with me. Thank you, John Paul, earlier tonight, for arguing with me. It was like this, and we got this all worked out, and then we realized we don't need an automatic napkin machine. That's not even what we were trying to do. But we didn't make that our first question. Our first question should be, is this good testing? Our first question shouldn't be, how can we make a tool control the computer? Our first question should be, what do we need to do to find bugs that matter and to find them fast? Any tools we can create to do that, that's what we should be doing, creating those tools. I did a little search for automated programmers and manual programmers, and I found this. Here's an automated programmer. Bach 1. Super Bot 2, automated IC programmer. What you're not seeing here when you search for automated programmer is any picture of a human. But when you look for a picture of automated tester, you can find pictures of people. I'm an automated tester. Why is it that people say, I'm an automated tester, or I'm just a manual tester? But we don't say that about programmers. We don't say, are you a manual programmer? Here's the highest quality manual programmer, the Flashpack 3, which looks decidedly non-manual to me, but I don't even understand what it is. It's some kind of EEPROM thing. Apparently, this is manual, but this is automated. They look exactly the same. I cannot tell the difference between the manual and automated. What is that? Probably the difference is one, you have to press the button to start it, and the other, you press a button that presses other buttons to get it started. I'm not sure exactly what the difference is. I'm almost curious enough to find out. Management has this fantasy. This is their fantasy. People who don't know anything about automation or testing, they want this. They want to rerun their old test to ensure nothing is broken. So here's the product, and here's the bugs in it, right? And the mothership comes down, and all the bugs ascend to heaven in Judgment Day. That's what they want, right? So this is only possible if your old tests cover everything completely with perfect oracles so that all possible bugs are found. But that's not life. This is what's actually happening, is your little tests are a smattering of fact checks, and maybe you find a bug, but these other things could sneak by because your old regression tests aren't testing everything, and they're not able to find all bugs. So it's not true that you need to rerun your regression test just in case the product is broken, so that you can prove that it hasn't broken. You haven't proved that it hasn't broken. You've at best possibly discovered a couple of things that are broken. That's at best what you can do. People who write automation and understand testing, we know this. But lots of us have sort of given up trying to explain this to management because they want to believe that the great golden mothership will come down and take care of all the bugs. And after a while you just go, well, why don't you just, we'll do our best and whatever. But there's a dark side to this, a real dark side. I talked to somebody in Romania. I was doing a similar talk to this in Romania, and somebody said that one of the problems that she had is that her management believes that the tools work well and do all these great things. So if she can't make the tools work well and do all those things, they don't blame the tool, they blame her. So what does she do? She stays up all night to try to work through all of the compatibility problems so that it looks to her management like it's easy. She has to make it look easy to them or they blame her and she's worried that she will be fired. Meanwhile, management is humored in their ongoing fantasy that automation is easy because they don't know she's staying up all night just to make it work. It's like we're treating management like they're children. We don't want them to know how their parents are working hard so that they can go to school. We want to make it look normal for them. All right, so in my 27-page article, I talk about mainly these 4 things. I'm suggesting that we stop calling this test automation. I don't call it test automation anymore because you cannot automate testing. All you can automate is fact checking. You can check the output, you can compare it against something else. That's not testing, that's fact checking. And fact checking is useful, And fact checking is part of testing, so I'm not saying it's bad. I'm just saying it's not all of testing. It's not even a very important part of testing, but it's an interesting part of testing, and I definitely want to do some of that. But I don't want to tell management that that's automating testing. It's not automating testing. It's automated checking. Automated output checking. That's what I want to call it. I'm a tester, and testers, among other things, we check output. And we can have tools help us do that. We can have tools completely automate doing that. But testing is so much more than that. Testing is the design process. Testing is the judgment of looking at output and deciding whether it's a bad bug or not a bad bug. It's knowing how to talk to people about what needs to be tested next. It's knowing how to talk about testability. There's all kinds of things that testers do, that good testers do. So I would like to say it's not automation, it's tools. Tools, people understand. I use tools. When you talk about a carpenter who uses tools, no one says, you mean carpentry automation? You mean an automatic building machine that builds my building for me? I love it. People don't go nuts like that. They think, oh, you mean like using a nail gun? Yeah, okay. You still need a carpenter. But yeah, a nail gun would be good. It would help the carpenter build the building more quickly. That's good. A power drill? Sure. Yeah, there's lots of tools that carpenters use without people saying, it's carpentry automation. So I'm going to call them tools just like carpenters call their tools tools. And testing is way more than output checking. And there are many ways to use tools, and we should let context drive our tooling. So I'm going to skip over some other stuff and just talk right now about what do I mean when I say let context drive your tooling. I mean this. I mean that here are some general variables, kinds of variables, families of variables, which I consider when I'm deciding what I should do in a situation. What do my clients want? What is my mission in this situation? What kinds of things can I do at a reasonable cost? And what kinds of impacts might those different things have? What are the costs? How long is it going to take to do those things? Long term, is it going to get better? Is it going to get worse? Should I think only about the short term here or about the long term? Maybe there's a value of learning something, so maybe it's not the best idea to use this technique, except I need to learn, so I might as well use this technique. To think about context is to say, what's going on here that might affect a rational decision about whether to use this technique or that technique? Like this. This is how I think about it. Imagine a scale where things hang in the balance. But what we're not doing is weighing one thing and another. What we're actually doing is we're doing a cost and benefit kind of calculation. We're saying, here's value, here's a valuable thing. Strategy B is a valuable thing to do, but it also has costs and it also has risks. So the risks are telling you not to do it, and the value of it is saying, yes, do it. And they might balance each other out, or in this case, the value is bigger than the costs. That's what's happening here. The value is bigger than the cost. So maybe I should do it. Because what that's saying is strategy B is better to do than to not do. But wait, there might be another thing that's even better to do. So that's why we don't just do something that's worth doing. We want to do the thing that's most worth doing. So there might be something like this over here with the same kinds of costs and risks, but maybe a whole lot more value. What we're doing when we're deciding whether to use a tool, what kind of tool to use, is we're trying to figure this out in our heads. What are the various benefits and costs? And we don't actually calculate this on a spreadsheet, or anyone who does is a fool, let me tell you that. Tool companies love to show you spreadsheets and say, you're going to save $2 million. The more test cases you do, the more you'll save. All that is propaganda based on simplistic assumptions about what testers do. So I can say in my 33-year career, I've never used that method ever for deciding what to do. I've never put together a spreadsheet and said, oh, this method is going to save us more money than that method. Wow. And I don't know anyone else respectable who has done this. It's possible somebody has done it who's respectable, but I've never seen such a spreadsheet that made sense to me. But what we do is we make lists. There's some good things, there's some bad things, and then we discuss them, and we get a feel with our clients, with our colleagues. I think it's worth doing this in this case for this reason, for this reason, and for this reason. And yeah, there's some risks, but you know, we should do this. That's how people make decisions in the real world. And there are downsides to that. I mean, look at the political system. Political systems work this way, and it's horrible. But that's the way people actually make decisions, is they kind of weigh different things, and then certain people become popular who shouldn't be popular just because they got, you know, a reality show or whatever. That's the way humans work. Now, in this case, this is something that happens a lot. In this case, this is actually the better strategy, but they choose this one instead. Why? Because they're biased. Because this isn't right in the middle. It's been pushed over this way, and they go, you know, this might be a better strategy, I guess, but this is what we know. This is what we're used to doing. This is the easy thing to keep doing. Maybe it's that kind of bias. There could be lots of different kinds of biases. But let me tell you a story about one kind of bias. Have you ever heard of Netflix? Huh? You have? Huh? I know. The executive vice president in charge of content. His name is Kevin McEntee. And when he graduated from college, I hired him. In 1988, Apple Computer hired him into the development system group, into my team. He was a college hire. Great guy. One of the first things I had him do was write me a test tool. We were inventing a testing language called Tesla. Get it? Test language? Tesla? And we wanted to create a compiler that would compile our test language. This is a stupid idea, but I wasn't around. 50-year-old James wasn't around to tell 21-year-old James that it was a stupid idea. So 21-year-old James just did it. That's how 50-year-old James knows that it's a dumb idea, because 20-year-old James did it. He tried it. And now I know it was a bad idea. But anyway, be that as it may, it was cool and it worked. It was just ridiculously expensive and overwrought solution to a simple problem that we could have used awk to solve. There were existing tools that we just didn't know much about, so we didn't use them. We were biased because we wanted to create something new, because we were kids and we were full of ourselves. And that's okay, that's what kids should do. But we hope that they learn from it, and I think I did learn from it. Anyway, I asked Kevin to write this compiler because he had taken a compiler class, so he's all college trained and everything. And he said, I'll do it, but I don't want to write it in C, I want to write it in C++. Oh, good, do you know C++? No, but I want to learn it. Well, I really think you should do it in C because you already know C. I don't want to do it in C, I want to do it in C++. So we argued, we went back and forth, and finally I realized as a manager, he would have no enthusiasm to do this unless I let him do it in C++. So I said, okay, go on. Took him 18 months. I gave him 6 weeks and he took 18 months. I never did that again. The next time I was in that situation, after 6 months, I canceled the project. I said, I can see where this is going. But I said, we pretty much we got to do this in 6 weeks. And he had like an alpha done in 6 weeks. But to get it done right, we wrote it, and then he tore it down and completely rewrote it, which took him another 8 months. So it was a total of 18 months. My group disappeared during that time. We were reorged out of existence, and we lost the need for the tool, and maybe you've experienced this kind of thing before. But Kevin is a talented guy. I mean, he's now vice president at Netflix. He's a talented guy, and he eventually delivered on this thing. But you see, he was biased. He wanted to do something in a language he didn't know anything about. And I was biased. I wanted to invent something and say I made a contribution to Apple Computer and we're innovators. That's what I wanted to do, just because of my own ambition. I wasn't thinking, this is the best thing I can do to test the product. I was thinking, this is cool. And now when I argue with people doing automation now, I just feel like I'm arguing with myself at the age of 22 and 23 and 24. People who go, it's so cool. Cucumber is so cool. People who created Cucumber, people who use Cucumber, I just look at it and go, you're making a complex solution to a really simple problem. Oh, but it's really hard for people to talk to each other, so we wrote this tool so that you can write programs in an English-like language that anyone can understand. You know what else people can understand? If you just talk to them. Why don't you just talk to them? I write code in Perl, and if you don't know Perl, I am happy to explain to you what my program does. It's really fun. We'll just have a conversation. I don't need to create an entire technological infrastructure. But you see, I'm being contemptuous and dismissive right now about something that I did when I was a young man. So I made this mistake. That's why I'm so passionate about it. I just want to try to save a few other people from being as amazingly silly as I was. I did learn from it, but I do think there are less expensive ways from learning these lessons than to have to spend 2 years developing an elaborate tool. During the same period, we tried to write a tool that helped one of the secretaries in our group deal with all the requests she was getting for services. So we thought we would create an online system for her where you could request things. And later on, I married a secretary. She's my wife now, my wife for 25 years. And now I know we're just dealing with someone who was a horrible secretary and didn't want to be a secretary. That's why she wanted a tool, so that she didn't have to talk to you. And she didn't have to talk to you, and she didn't have to talk to you because she hated talking to people. So she wanted us to create an online system so that she wouldn't have to interact with people. But my wife is a really good secretary, and she knows that there's a simple solution to all this stuff, and that's just let people come to you and talk to you and ask you things, and then you can just write down what they want on a piece of paper and then make a to-do list, and that's all you have to do. If you have basic skills, you don't need a whole system. But why were we creating a system? Because I thought it would be really cool to create this automated system, so that's one reason why I didn't argue about it. I just thought, what a cool idea. I want to work on it. All right, here's the Cdt Learning Paradox. I just named it, just tonight. The Cdt Learning Paradox. For your viewing pleasure, context-driven testing means choosing the right solution for the situation. To choose the right solution, we need the right skills. To gain the right skills, we've got to practice those skills to develop them. Practicing means doing things that we aren't good at yet. What would practicing to get good at something mean if you were always already good at the thing that you were practicing? That would be like, I've got to practice my breathing. Like, you're already really, really good at breathing since you've ever been alive. I don't think you need to practice your breathing technique. just to stay alive anyway. I mean, you might for some artful purpose, for a demonstration or something, but really, practicing is useful if you aren't already good at it. So that means to get good at context-driven testing, we must sometimes do things that we aren't good at in order to practice them so that we can get good at them so that we can be good at CDT. Therefore, choosing the right solution for the situation may require us to choose the wrong solution for the situation. And here's an example of that. This is a UML extended state model. Have you ever done a UML extended state model? You have? I went my whole career and did one of them. That's the one that I did. One time. UML extended state model. Why did I do it? Did I lose a bet? Was it a drunken dare? No, what happened is I was testing something and I thought, you know, this is a very state-intensive system, so I'm going to use a state model for this. But there were too many states to use a simple state model. So I thought, I wonder if there's a better kind of state model. And I looked it up and I found out it's called a UML extended state model. And I thought, maybe I could try that. I've never done that before. And then another part of me, like the little angel part, said, but James, that would be a waste of time. You don't really need to do this, do you? But the little devil part said, well, it would be cool. And it's really cool and technical looking, and you could show it to people and act all nonchalant, like, yeah, I do these all the time. And they'll go like, you're a genius. And you go like, yeah, I get that a lot. So I created one of these, and I showed it to my client. And I said, after I did it, I said, you know, I think this might be a little gratuitous and unnecessary. I'm not going to put it in my test report. And he said, oh, put it in your test report. It looks so cool. So I said, okay. But I also found, while he looked at it, he found all these mistakes in it. And I realized that making one of these is just as hard as writing code or writing specifications. Just because it's a diagram doesn't make it less error prone, because this is complicated. All these semantics that you got to put. All this is, by the way, is a depiction of a volume control for a remote control for a television. That's all this is, and it's this complicated. And it's not just that. It's a volume control that you can also control the volume on your smartphone. So it's you can connect your smartphone and do it, and it knows if you're connected or not. And so that's why there's a connected, disconnected, muted, not muted, and there's all kinds of little rules and stuff like that. So I did this. Why did I do it? What was my real motivation? My real motivation is I gotta learn. And to learn, I have to do some things which are not the most efficient things to do, because someday I'm gonna need to do this skill maybe in real life under fire. And I don't want that to be the first time that I ever figure out, how do you work a fire extinguisher, you know? They used to do this at Apple. They would give us little fire extinguisher classes just so that we'd be ready in case we needed to use a fire extinguisher. And they'd take us out to the parking lot and we'd waste a whole lot of fire extinguishers putting out fires. And you get kind of comfortable. You go like, oh, you just pull the pin and squeeze it. That's pretty easy. But I'd never done it before, so I'm glad it wasn't a real emergency, which is the first time I ever used one of these. So we wasted a lot of time and did things badly, but we do it so that we can do it well. Anyway, that's the story of this monstrosity. All right. Now I'm going to show you another example, and this is an example of using tools in an interesting way that is not attempting to replace humans or be a human. I'm just trying to excite your imagination here. Now, because I am who I am too expensive for people to hire to do testing anymore. No one hires me to do testing unless they're being sued by somebody. Then I might be hired. I'm on a court case right now. I'm very excited about it. Doing expert work involving automation right now. And in my article, we had this big section attacking a particular automation vendor. And at the last minute, Keith Kling convinced me to remove it. He said, you're attacking this vendor, and we don't want to upset them. I'm like, I want to upset them. And he said, no, please don't. So I said, okay, I'll remove it. Turns out that vendor hired me, so I'm really glad. Now, I am actually really glad that I didn't put that in. I feel, am I wrong to think, I feel like a little sick that I should think that, but, because I really do think they're messed up, but I'm happy now that they want to hire me. That works. So anyway, it's a lawsuit thing, and I think they're right, so I'm going to help them. But anyway, what I have to do, you see, is I have to make up fake test projects in order for me to practice. Because I can't be going on the basis of stuff I did in 1995, right? I gotta keep my skills as current as I can. So I was coaching somebody, and I decided to give them a challenge. I said, why don't you test the distribute function in Inkscape. Inkscape is a drawing program. It's a wonderful drawing program, free drawing program. It's kind of like Adobe Illustrator, and I love it. I use it for all my diagrams these days. So I said, bring up Inkscape and test the distribute function. Let me show you what the distribute function does. If you have a bunch of objects like this, then you can say align and distribute, and you can click over here, and there's different ways to do it, but I'm going to distribute them by centers right now. See? All it does is it makes sure that they're evenly spaced according to their centers. That's all it does. So I thought this would be really easy to test for this student of mine. But while she was doing it, I started thinking about it and playing with it myself, and I realized it's a lot more complicated than I first thought. And it became a very interesting little testing challenge, so I decided I was going to try to pour my skills into doing this. So here's one of the things I did. I wrote this program. It's poorly formatted because I did it so quickly. And what this program does, let's just make it a little bigger so we can see it a bit. Okay, excuse the poor formatting. When I write something very quickly, sometimes I don't make it very easy to read. But all this does is this creates a huge matrix of little squares and puts it in an SVG file so that I can do this. There, see? This is that file. This is 10,000 tiny squares. Now I could have just made a little square and then copied it and put it next to the other squares, but I used a program to do it. I'll use a little automation to do this so I wouldn't have to. And there it is, 10,000. Let me show you now what happens when you do a distribute on 10,000 squares. It takes a moment, but then it does this. And then I do it on the y-axis, and I get this. There you go. And this surprised me. Maybe it surprises you too. I guess what I thought would happen is I would see like a square, and everything would be evenly spaced, like a grid. And instead I get this weird, almost circular thing, and then it's got those weird lines in it. So I'm looking at this, and I go, there's 10,000 objects, they've been distributed, now I have only one problem left, and that's to answer the question, so is it correct? Is every little object in the right place? I don't feel like doing this by hand. I don't know about you. So what do? I immediately look for a way to grab onto this programmatically, and I like to work at the lowest level that I can. So I got into the SVG file, which is a text file. See, what you might not know about these diagrams is that they're saved in a format that's a text file format, which means you could, in principle, just read it with your eyes, and it'll tell you the X and Y coordinates of all the objects. It's really cool. So I wrote this program. this program, which started out taking me, 15 minutes to write, and ended up taking me, I think, 3 hours to write it. 3 hours to write this. Why did it take so long? Because it turns out that SVG files are not simple. They don't just have X and Y coordinates. They have X and Y coordinates, and then they have a matrix, matrix calculation coefficients, and you have to do matrix mathematics. So I had to go to Wikipedia to download data. You know, just like Trinity, who says, now I can fly a helicopter, I had to do the download process and go, now I can do matrix math. So I had to read the SVG spec, a little bit of the SVG spec, and basically figure out how I could actually get the coordinates, which initially I thought would just be right there. But now I have to do a little cooking and a little waiting for the yeast to rise and all that. So that ended up being this. So it took a few hours. This is one of those examples that I'm talking about where, you know how I said this automation girl in Romania was saying that my management thinks it's so easy, but I have to stay up all night to do it. It's exactly that kind of thing, where they say, it would be easy, just get the XY coordinates out of the SVG file. And if she doesn't do it quickly, then they'll say, what's wrong with you? Are you an idiot? So I had exactly one of those moments where you step into a puddle and you fall up to your knee in it, you know? And that's this. Well, by doing that, I ended up with this. I had a whole bunch of data, and I brought the data into a system called R, which is a data analysis language. It's a wonderful thing. It's really worth learning R if you're a tester. R. I hate these languages, right? Is it like a joke? Is it a prank or something that people like name their languages the? And then you say, oh, I learned a new language. What did you learn? You know, the language. I know. What language did you learn? Like, I learned what last week? What? Yes, what? This week I learned the. There's that language I use called processing, and I hate it because it's just an ordinary word processing. Couldn't you have done any, like maybe changed a word to a Y or something, called it processing or something? And so anyway, this is called R. And R is a statistical analysis package that has a language built into it. It's a weird language, but after a few days you kind of get the hang of it. And I decided a couple years ago that I had to learn R, so I made up an excuse. I created a testing problem and used it to learn R for about a week. And so that's why I'm able to say R in this situation, and it doesn't take me too long to do this. Here is a set of things that I did. This is actually not the one I want to do, though. I want to look at this one. This is the one. Okay, this is the one I just showed you. This is, in R, a plot of all of the original object, taken right from the SVG file. This is a plot of the new object after the distribution, taken right from the SVG file. You can see it's got those same weird lines in it like that. So I reproduced this picture because I wanted to confirm that my program really does know the X and the Y coordinates. I look at this and go, this looks like the distribution that I saw when I look at it in Inkscape. So I think that this R has it correct. Then what I did is I took all the X positions and I sorted them, so now they're in order. And then I found out the gaps between all the X positions of every object on this diagram. And then I took those deltas and I sorted that. And I get this right here, this shape. Now, you can't really see the number there, but it says 0.1399, 0.1400, 0.1401. Basically what that means is the distribution command worked. It created this set of objects such that if you look at the X positions of every single one of these, and you organize them, they're almost all identically different from each other. Just each one is a little bit more over by about 0.14 pixels. 0.14. So that's exactly what I expect. Some are a little more, some are a little less, but they're so close that I would say the distribute function has succeeded. That's what it feels like to me. Now I could show this data to my client and convince them, I think you have a pretty good distribute function there. But wait, a tester doesn't just create a check like this and say it works. The tester now has to say, what other scenarios are there? Maybe it works in some scenarios and not in others. So I came up with some different ideas, and one of my ideas was this one. I took a circular object, here's a good one, a circular thing, a bunch of things arranged in a circle. So it looks kind of like that. I'll cut it out. It looks kind of like that. And when I did a distribute, I got this, a weird diamond shape. But it still looks like maybe it worked. It's distributed, it's sort of. But when I ran the numbers on it, I got a weird result. And here's the weird result. Some of the differences are close to 0, and some are as large as 20 pixels. That's a really different kind of result. Here was it before. Before, it had a range of up to 15. 17 or something. After, the range is even higher. It's like it anti-distributed. I think this is a bug. I think it is. I'm ready to go to the developer with this. I haven't done that yet. It's not because it's a fake project. I don't even know who the developer is. I guess I'm gonna have to go online and ask around. Why is it that in one case it does the distribution perfectly, in another case it does the distribution and it gets it all messed up like this? I have a theory. Here's my theory. When I was playing around with the SVG file, I found out that Inkscape uses many different methods to move things around. Depending on what commands you use, if you take something and drag it and put it in a particular place, it does a certain thing in the SVG file. But if you use a command that automatically moves it, it does a different thing in the SVG file. It still looks the same on the screen, but the underlying data structure is a little bit different. What I did to create this circle is I used a circular arrange command. I didn't actually put them in a circle like this. I used this arrange command, and this arrange command did a special matrix transformation that moved all these things over. So inside the SVG file, each one of these objects has the same XY coordinates, but a different matrix transformation. I think the distribute command gets confused by that. Now, before I knew this, before I looked at the SVG file and saw what was going on, I would have been totally baffled. I would have said, there shouldn't be any difference. If the distribute command works here, then the distribute command should work there. They're just objects. But now, because I used my tools, because I had to get in that data and grab it and manipulate it, I happen to have learned more about the underlying data structures. And now I know there's distinctions, there's differences that I didn't know about before, which means that I can do smarter testing. I know that I can't just do one distribute. I have to try every different kind of object that has been arranged in every different kind of way, potentially. While doing that, one of the things that I and my students discovered while doing this, because I've been challenging students to do this now for a couple of months, is that if you try to distribute 3D objects in Inkscape, they won't work. They won't get distributed. The distribute command ignores 3D objects. But if you take a 3D object and you ungroup it, and then you group it again, it looks exactly the same, but now the distribute command will happily move it around the screen. But it's lost its magical 3D powers. By deeply testing the distribute function, I have come to learn deep, new things about the details of how this complicated drawing program works. I'm doing test tooling. I'm using tools to help me test. I'm using them the way we use washing machines to wash our clothes, though. I'm not using them in the way of make a humanoid robot that will text my wife kind of thing. But I'm using tools that magnify, that speed up, that enhance my abilities to see things. Let me give you one more example. I was telling some people about this morning, but most of you I haven't told about it, so the rest of you will have to bear with me. How about this? When you do a distribute, it's supposed to distribute the objects, right? Of course. And that, we've already seen what that looks like. So, what you see here is special test objects that I made up. And these test objects are especially easy to do distribute testing with because they have little lines on them and little green bars. What that means is that I can move these things around like that, then I can select everything and I can say distribute. And I see that they all snap right back to where they were supposed to be again. And I can try rearranging their order, and I can basically do various precise experiments with distribution by using my little pre-created objects. I didn't use any software to create these objects, I just used Inkscape to do this. But while I was doing this, something occurred to me. It isn't enough that distribute works in the sense that it properly distributes the objects. It's also supposed to not mess up anything else in the document, right? How do we know? How do we know it hasn't messed up anything else in the document? What would we have to do to prove that it didn't? Or to at least collect evidence that we didn't? Does anyone have an idea of how we might do that test?
Refreshing test.
What do you mean?
Sorry, was a joke.
Refreshing test?
Well, I argued that they didn't have any values, so I thought that would be a nice one.
What are we talking about, James? So, messing up the file structure or messing up other pictures that are in the same image?
I have a document. The document has stuff in it. How do I know that other stuff doesn't get disturbed when I do a distribute? So that when I've accidentally corrupted my document, but I don't realize it. I've knocked something else out. I've changed the color of something. I've twisted something that wasn't supposed to move at all. How would I know?
Check it.
How do you check it?
By looking at the document if something changed.
Oh, okay. Let's try that. So you're going to find out that it might not be all that easy. Here, I will. I'll show you my idea, the first part of my idea, and then we'll. Oh, that's the wrong one. Is it this one? That's the one. Okay, let's do this, and let's do the. Let's open this. This is the original. Here it is. I went online and I found the most complicated SVG I could find. This has some like 500 parts to it. This is some Italian Hadrian's column thing that somebody did, and they put it into SVG format. And then I took my little test objects just like this, and I selected my test objects. There we go, just like this. And then let me select this one. Okay, good. And then I did a distribute, line and distribute, and boom, like that. All right, see? So wait, but did I mess up at the rest of the document? How would I know? Can you just look at it and tell? Is it that easy? There's only 500 parts here. How do I even begin to take it apart? Do I just like grab things and move it and go, well, that looks okay, let me put it back. Well, that looks okay, let me put it back. I mean, it's a bit problematic, right?
No, but you can take out your test objects and do a compare.
How am I going to compare them? What specific way will I do a compare?
SVGs?
SVGs, you can do.
So I'll just compare the two SVGs.
Yeah.
All right, of course. That's what I did. I compared the two SVGs. So here's the result. Here's what actually happened when I did that. I used a little tool called WinMerge, which is not the best tool for this, but it's pretty good. I'm expecting 8 changes. Why? Because I had 10 objects, and the 2 objects on the end do not move. So that means 8 things will move. There were 10 changes. The first one is the name of the document. Okay, I'll give you that. The name of the document, that's okay, because I saved the document as original. It's called new. So, all right. So, but what about that 9th one? There shouldn't have been 9 changes. So I went down and I looked at every change, and I'll just fast forward you to the actual offending one. It's right at the end. And this is an example of why we don't use tools, and it's why we don't let tools run the world. Here's why we don't let tools run the world. Okay? It's because of this. The object that wasn't supposed to move on one of the ends did move from 779.80575 to 779.80573. It changed, and it wasn't supposed to. It moved by 2 100,000ths of a pixel. Fail! No. Tool. Calm down, tool. Fail, fail. No, tool. Shh, tool. It's like, I feel like I'm dealing with a barking dog with my tools sometimes. You know, like I'll drop a book and my dogs go crazy. You know, we're being attacked. Go to the mattresses. Attack everything. And sometimes my tools are like that too. If we had a simplistic attitude about this, we'd say, that's a fail, that's a bug, it shouldn't have changed. But if you look at it in a reasonable, risk-based, meaningful way, then you say, this is not a problem. In fact, I think I know what happened. I think what happened is the program brought in the inputs of these coordinates, and it spit out the resulting output coordinates. But what happened is, it brought the coordinates in, put it in a variable, and when it took it out of the variable and put it back to text again, it was a little different because of a numerical precision issue. That's it, it's just a little numerical precision, a little rounding thing. Now, if we were sending a probe to Saturn, then I guess we have to sweat those details. But this is probably not one of those programs that's used to send probes to Saturn. If it is, then I guess this is a mathematical precision issue that we need to follow up on.
But why does it occur to only one of the objects and not on, I don't know, 10?
Shut up. No, it could be because the other one doesn't have as many digits. You know, maybe it just, this one just happens. It only happens in the very last digit. So, I mean, that's my theory. Now, I think this is a bug in the sense that you could certainly imagine how they could write this thing. They write the distribute function so that it doesn't even touch the endpoints at all. It doesn't take them in and then spit them out again. It just never takes them in and never, or it would have to take them in to do the analysis, but it doesn't have to spit them out again. Or if it does spit them out, it could spit out the exact text that it took in. It's not hard to see how the programmer could fix this. But at the same time, I'm going to mention it. I'm going to tease the programmer about it a little bit, maybe. I'm going to mention it, but I'm not going to make a big deal out of it. And that's the thing, is that when we use tools to do this checking, the tools tend to be very, very severe, unless we tell them not to be severe. But if you tell them not to be severe, then it'll turn out there's some case where it should have been. There was a case at Facebook that Garanka Biedov told me about. She's a performance tester at Facebook. And she said that the Facebook managers wanted her to automate not just the performance tests, but reading the graphs that resulted from the performance tests. They didn't even want to read the graphs. She said, no, you shouldn't do that, because when you read the graphs, you see unexpected patterns, and so they got someone else to do it. That guy automated the graphs. Then they had this huge problem, because it turned out that the guy put in some alerts, but he forgot one alert. He didn't put any alert in the case where a test suddenly got a whole lot faster. Like something that normally took several minutes takes 3 seconds. And his program was just going to give an alert if it took longer than a certain amount, but not if it was really faster. Why was it faster? Because it was actually failing. The system was not actually doing the test. That's why it was so super fast. But since the programmer didn't have the imagination to see that at the time he wrote the code, and since no one was actually looking at the graphs to see, that's strange, this is suddenly super fast, that can't be right, they missed it. They missed this big performance problem until users began complaining. So she uses that as a little example of, overzealous, silly automation. We need to carve out a human place, a fundamentally human place for responsibility, for judgment, and we need to sustain that by making it interesting for humans to be in that place. It's not enough to sit behind the wheel of a self-driving car just in case it suddenly needs you. That doesn't work, actually, because humans lose their skills. This is why the Airbus 320 that crashed in near Indonesia, not the 777, but the 320 that crashed about a year and a half ago, 16 months ago, something like that. Remember? The final report on that came out. Did anybody read that? Do you know why it crashed? We now know why it crashed. We know exactly. The thing was in turbulent weather, was in bad weather, and suddenly it just went and smashed. It was bizarre. And then they got the black boxes pretty quickly. Took them a while to figure out what happened. Want me to tell you what happened? Because it was an example of too much trust in machines and people losing their skills because of it. It's an important cautionary tale about automation. What happened is there was a little broken bit of solder in a rudder control unit that was getting worse and worse because of thermal expansion that was causing an intermittent loss of data going to the flight control computer. The flight control computer was then giving errors. What did they do? They replaced the flight control computer. That's what you do when your dog barks all the time. Replace the dog. Replace the dog. Replace the dog. And it turns out there's a rotting corpse under your house. So they never replaced the rudder control unit. They just kept replacing the flight computer again and again. But there's another thing they did. Sometimes they didn't replace the flight control computer. Sometimes they just rebooted it. And the problem would go away. The pilot saw that. And one day, in the middle of a flight, the flight control computer, which is very important, by the way, was giving this weird error. So the pilot decided, I'm going to reboot it. Just take 30 seconds. He'd seen them do it on the ground, so he decided to do it. The Airbus manual says, do not do this unless you really know what you're doing. That's actually what it says, unless you thoroughly understand the consequences, I think is what it said. The pilot believed that he thoroughly understood the consequences. So he deactivates it, reboots it. As soon as he does this, the flight control software switches to a backup software, which works differently than the main software. It's called alternate flight law. That's what they actually call it. Alternate flight law. Normal flight law does all these special compensations for different weather conditions and different load and balance issues. Alternate flight law is really simple. It doesn't compensate for all these things. So what was happening is the co-pilot was sitting there holding the stick. But the software changed underneath him, and it interpreted his stick position differently and his rudder positions differently, and he didn't realize it. And it starts rolling the plane. The report says for 9 seconds, the pilots did nothing until the plane was at a 60-degree bank. Only then did they realize something was wrong, and then it started doing this. And the pilots weren't trained for what to do, and they crashed a few moments later. Airbus didn't train pilots in what to do in that situation because they said it will never happen. What was the basic problem? Well, the basic problem was this rudder control unit had a problem, and the maintenance guys kept replacing the wrong thing. That was the main problem. But after that, the next problem was the pilots didn't understand their own aircraft well enough because they were always flying with all of this software. And when the software changed, they had no practice, not an insufficient knowledge of how the flight dynamics were going to change as soon as they deactivate this computer. Even though the computer was deactivated for only 30 seconds or something, that was enough to get it to roll and fall out of the sky. And a few moments later, like a minute later, they smash into the water. That's an example of humans who are tool jockeys. They've become tool jockeys. They know how to push the button, and then they just trust that things are going to work. We need to carve out a place for humans where humans understand enough about our tools because we keep pushing and practicing and trying different things and deactivating our systems sometimes just for the fun of it, just because we've got to learn and experiment. So I believe in tools. I think it's fun to do this. And this whole testing the distribute thing, in a way, testing distribute here is totally not context driven. Because I was testing something that I had no reason to test, which is the antithesis of context driven work. Context driven says, don't do things you don't need to do. Solve real problems, not fake problems. But I have to solve fake problems in order to learn to solve real problems. That's true for airline pilots. That's why my brother, who's an airline pilot, likes to fly without the autopilot. Because he says it keeps me sharp. It forces me to be awake. And he sometimes flies with people who only fly with the autopilot. And they say it's safer with the autopilot. So there's a big argument between two professional pilots. One who says it's safest to be with the autopilot, and the other guy who says we're getting less and less skilled when we rely on the autopilot. So in the long run, in a deeper sense, it's safer not to have the autopilot. It's an argument. It goes back and forth, and it's a real controversy in the flying business about this. My brother's in the middle of it. And I'm in the middle of this controversy, where some people think, let's just make tools do it so that we can push buttons and everyone will be happy. But I'm wondering about that humanoid robot on my lawn, and I'm wondering, if he suddenly breaks down, will I know what to do? Anyway, that's why I don't use those automatic thermostats that talk to the internet. That's not for me.
Then again, if your humanoid robot pushing your lawnmower will break down, at least you could still push it. Try that with the robotic one without the handle.
You have thought of a wonderful reason why we should just have humanoid robots do everything. General purpose humanoid robots, because we can unplug them and we can use our human muscles for all that. I guess that's true. So,
Then again, why
strike that. We should have humanoid robots for everything. There are some advantages to that. This is the kind of interaction you see that we have to have. What we should be doing is debating, is practicing debating, understanding the pros and cons. One of the big problems with the automation issue is people who say it's right to automate, you should just automate everything you can. That's not an atmosphere where people are thinking for themselves, where people are debating. That's an ideology. I guess I'm pushing an ideology too. My ideology says we should exalt human characteristics, we should celebrate human diversity and all the different flavors and sizes and shapes that people come in. That's what I think we should do. I'm a humanist. So that's my ideology. I think that makes a better world. Okay, but I guess, you know, there are different people who have different opinions about this. Anyway, that's my talk. If you want to, you can read the 27-page article. It's got a bunch of examples and stuff in it. It doesn't have this example with distribute because it's just really new and just recently did this. But just wanted to show you how you can absolutely use software, use tools, use technical skills. And that's a kind of automation, but it's not a kind of automation that diminishes us. It's the kind that makes us bigger and better than we might otherwise be. Thank you very much.